All right, hello and welcome to the second day of capstone presentations. My name is Dr. Robert P. Shoemaker, and together with my co-teaching colleague, Dr. Lidong Wu, we welcome you to today's presentations. Today we will be hearing from PerpHect Pool Solutions and Sportle. PerpHect Pool is modern pool solutions. Their product is to take the guesswork out of pool maintenance by monitoring pool water data quality 24 hours a day, 7 days a week. Users can have precise readings of their water quality from a simple app on their smartphone. So sit back, relax, and let PerpHect Pool do the hard work, knowing that your pool's information is just a click away. And with that, I will turn it over to Mr. Pavlovic and PerpHect Pool. Mr. Pavlovic.
Milos, you're muted.
Yeah, you have to unmute yourself.
Hit Alt-A. Everybody.
All right, can you hear me now?
Yes.
Yes.
Yes. Go ahead.
Great. Sorry about that. So my name is Milos Pavlovic, and today my team and I will present you our product called PerpHect Pool, which was based on my idea of modern pool maintenance solutions. So how did I come up with this idea? While thinking about how my family and I maintain our pool back home, I remember that we would use testing kits similar to the ones displayed here to gather our pool's information. We would grab a sample of water, add some testing solutions to it, and then by the process of eyeballing, we would estimate the results. And so when I remember that, I realized that this process seems a little bit outdated considering today's age of technology. And I thought, wouldn't it be great if we could forget about those testing kits and instead have a system composed of a device and a companion app that would do the hard work for us, and we could simply just see the results on the app. And so that's where our system comes in play. With PerpHect Pool, we can throw away those testing kits and turn to a modern and more convenient way of monitoring our pools. This is our product overview. So our product is an Internet of Things-based pool monitoring system that takes the guessing and eyeballing out of the equation when it comes to maintaining swimming pools. With PerpHect Pool, you can monitor your pool's water quality 24 hours a day, 7 days a week via simple phone application. And always know that the precise readings of your pool's temperature, chemicals levels are just a few button clicks away. Now let's look at our prototype analysis. Listed here are the functional and non-functional requirements that were needed to be incorporated within the system. These requirements were set up at the beginning of the development phase, and now they have been fully implemented. So with PerpHect Pool, you can measure your pool's temperature, pH, and ORP. Our system will also maintain pool's information history details for review and tracking. And our system will also display status messages regarding the current pool's water quality. As far as the non-functional requirements, three main ones that we wanted to incorporate are performance, energy efficiency, and readability. Our system is able to quickly and efficiently collect data, analyze it, and display the proper results. PerpHect Pool is also able to switch to a mode in order to pull and process new data only once per hour. And for the convenience of our customers, our system also charts the pool's information history for increased readability. On this slide, we have the illustration of our use case model, which describes the interaction between the user and our system. The user will interact with the system by monitoring pool's information. The process of monitoring pool's information is further extended by 5 more use cases. The user will be able to view pool's temperature, ORP level, and pH level. And in addition to that, the user will be able to see the information history through the previously mentioned charts, and also the status messages regarding the current pool's water quality. Now, in order to make it possible for our users to view pool's temperature, ORP, and pH, our device will need to measure those corresponding values. And now I'm going to pass it to Daniel McKenzie, who will introduce you to our prototype design.
Thank you, Milos. So this project was very fun to work on. We got exposed to lots of new technologies here, and I would like to start here by explaining some of the hardware we used. So primarily our Arduino Mega 2560 microcontroller controlled all of our sensors and our wireless connection. Attached to that, we did have to attach an ESP8266 Wi-Fi module. The Arduino Mega does not include Wi-Fi built in, but we were able to get that to work by using an adapter module that in addition to that, we have a digital temperature sensor, analog, ORP, and pH sensors, which take our primary readings from the, and of course a power supply, which for this system we've been using a 9-volt battery, and we have now extended on to 8 AA batteries. We'll demonstrate a little bit of that later. Software-wise, we of course worked with the Arduino programming language, which is very similar to C. We use the Blink API. We'll demonstrate some of that in a moment. And ESP8266 for Wi-Fi connectivity has included libraries. OneWire and Atlas are the libraries we use to get readings from our sensors. On this next slide, we'll talk a little bit about the architectural design of the system itself. So I'm going to start down from the sensor data, where we actually harvest these readings. We're pulling the pH, ORP, and temperature directly from the pool, obviously, and we're going to store this locally in the Arduino. And the Arduino has a somewhat limited storage capacity, so it's really wise not to keep it too much information in there. So what we've done is at each reading, we'll take 10 readings of the water, and then we'll take an average reading of that and store it locally in the Arduino. Now we'll only store 30 days locally in the Arduino. Once we collect that information, however, we do push it up by making an API call to Blink, and we'll transmit those values over to our PerpHect Pool app. Where in the PerpHect Pool app, we can store up to 6 months of values. Readings. The method I just described operates once per hour, and that's so that we can save energy by turning the device off and reconnecting to the Wi-Fi. Alternatively, when the user is actually using the app, we can pull this info through the Wi-Fi, and actually we can pull it through cellular data as well. So in there, the user is able to view a live reading of what's actually going on in their pool. Usually that's not a great idea if you're trying to get ORP readings, but if you are trying to adjust some other variables like your pH, or if you're just wondering what exactly your pool's doing at the moment, that's what we do. So on the next slide, we have a little bit of our prototype GUI here. At the very top, you'll see the temperature and pH level and ORP, as well as the accompanying status messages next to them. Now these all have different ranges in which you'll see these status messages. I won't explain all of them here to you. I will point out that the ORP only has a low threshold of 650. Very clean water can have extremely high ORP up into the 1000. So we've left off that. It won't actually tell you if you've got too much sanitizer. That's something that you should keep track of yourself as a pool owner, not to go swimming immediately after you drop a bunch of sanitizer in your pool. On the right there, you'll see the history charts we've been talking so much about. And at the bottom, you'll see some date ranges or some time ranges you can change. We'll demonstrate more of this in our video, which I believe is on our next slide here. So if you guys don't mind, get comfy and enjoy this video of the PerpHect Pool. Introducing PerpHect Pool. The PerpHect Pool is designed to give homeowners and commercial pool operators accurate insight into their pool's water quality and help them maintain a beautiful pool, all from the convenience of their mobile phone. This video will outline installation of the PerpHect Pool device and app, as well as describe the functionality of the system down to a hardware level. The PerpHect Pool system should be installed away from high-trafficked areas if possible. Included are 2 strips of outdoor tape. The user may opt to use the base screw mounts for more permanent installations. Once your base station is affixed, you may now connect the pH and ORP probes. For the pH probe, take the silver connector and attach it to the corresponding silver BNC port. Now do the same for the ORP probe. Your temperature sensor comes pre-installed with the unit. The probes may be attached to the included suction cups or left freely suspended in a corner of your pool. The probes are waterproof and may be left in your pool indefinitely. Now carefully remove the storage caps from the pH and ORP probes, taking care not to spill the potassium nitrate storage solution that's included. Carefully lower the probes into your pool. Now the PerpHect Pool system is installed, and we're ready to install the companion app. The app is compatible with both Android and iOS devices. Download it from the App Store and launch. On first launch, users should create a new account by providing an email address and password. Returning users may log in with their credentials. You're now ready to add the PerpHect Pool to your home network and provision the device to your account. Tap the Add Device button. First, supply the Wi-Fi credentials of the network your device will use and tap Continue. Make sure your PerpHect Pool is powered on before continuing. Now, your PerpHect Pool's broadcasted network should be visible on the screen. Select the device to finalize the pairing process. All right, now you're ready to use the PerpHect Pool system.
Now, let's take a look at the main hardware components of our device. To open up the box, simply unscrew the 4 corner screws and remove the top. Our device is running on the Arduino Mega microcontroller board that is powered by a 9-volt battery. For a longer battery life, we're including an 8-pack of AA batteries as well. Inside the box, we also included a USB cable that can be used to connect the device to a computer and perform troubleshooting if necessary. The device is connected to the user's Wi-Fi network through an ESP8266 Wi-Fi module that is linked to our microcontroller. Next to it is the LED light that was turned on by pressing the LED button in the application's home screen, indicating that the device is connected to the Wi-Fi. In the top left corner, we have our three main sensor circuits. These sensor circuits are connected to their corresponding exterior waterproof probes. Here is the pH circuit, this is the ORP circuit, and this is the temperature circuit. After receiving the data from the probes, both pH and ORP circuits are sending the information by transmitting analog signals to the microcontroller. On the other hand, the temperature circuit is sending digital signals directly to our microcontroller. The data is then analyzed by our code and used to compute all of the necessary values, which are afterwards updated on the application's home screen through the cloud.
Now we'll demonstrate the functionality of the PerpHect Pool. Our phone is not connected to Wi-Fi. Our data is sent to the cellular networks so you can monitor your pool from anywhere. The PerpHect Pool is connected to the local Wi-Fi network. The user can check connectivity by turning the LED inside on or off. It's recommended to leave the LED off to conserve power. Additionally, a message is displayed in the app when the device is offline, along with the time it was last online. For the purpose of this demonstration, we've filled this 5-gallon aquarium with tap water. The readings we see are consistent with what would be expected of this water, with pH about 7 and low sanitizer concentrations. The temperature is displayed at the top of the screen, followed by pH and ORP, which is used to measure sanitizer concentration below. First, we'll add some warm water to the tank and observe the response of the temperature sensor. As you see, temperature increases slightly and then normalizes after a few moments. Now, we'll add some chlorine to the system and observe its effect on ORP and pH. ORP begins to increase along with our pH, which becomes more basic. Now, let's take a look at some of the other features of the user interface.
For the last part of the demonstration, we have grabbed a sample of treated pool water with the pink cup to the left of the screen and submerged our sensors in it. We can see that the constantly updating values are showing the pH level being close to 7.3 and the ORP staying above 650. That should mean that we have a properly treated pool, which indeed is indicated by the corresponding status messages. After the device has collected and stored a certain amount of data to the cloud, users will have the previously mentioned 3 history charts. Each chart is featured by the ability to choose among different time frames for obtaining the desired information. The charts can also be viewed in the full screen mode by clicking on the full screen symbol. The users will also have an option of exporting these charts to CSV files by clicking on the 3-dotted symbol, after which they will choose to either export the data or erase it if they desire to. Once the export option is selected, the chart will be sent to the email that was used to register the account.
Thanks for watching this demonstration of the PerpHect Pool system.
All right, thank you guys. Now, Rachel Kennedy is going to come and talk a little bit about our backend services. Rachel? Rachel, you're muted.
Thank you. Sorry about that. Experiencing a slight delay. So the backup services here that we're using at PerpHect Pool are going to be our Blink cloud server. We're currently running the free prototype version, which hosts up to 20 devices. That was actually a large part of why we chose to use Blink. It lets you host several devices while running on a prototype version, making it but the pricing also scales up quite nicely with a startup bundle that holds 1,000 devices at about 16 cents per device, and a business bundle that holds up to 5,000 devices at a monthly rate of about 1 cent per device. Next slide, please. So the PerpHect Pool stores all of their user data on a private cloud through the Blink API, and the platform provides that dynamic provisioning that we need of the devices to connect all of our user accounts securely using their password information and encryption. So I'm going to pass this on to Montrell, and he can continue to tell you about the back end of our website.
Hey, so excited to be here to represent PerpHect Pool today. I am the system support specialist for this project, and today I'm going to tell you why we use a multiple site server powered by AWS to do our website. Um, Very easy to use. It's a WordPress installation that allows you to create and manage a network of multiple websites. Saying that we have two business developers in our project, we decided to go this route so we wouldn't have two different domains or IP addresses to promote or try to sell our websites. And below in the picture, we have what is a little example. So it shows the main IP address, and then we have two subdomains um, that Jake and Peyton use to actually customize and design their websites. And if you could, can I get to the next slide, please? And why we use the multi-server site, or the multi-site website, I'm sorry, that just means that they had their own separate folders that they could store their images, uploaded files, and so that one person couldn't access the other groups or the other person's files, just for security purposes. And this was just a competitive way for us so that we can get our guys out there trying to get this product promoted and put their own unique twist so that they could sell, or promote the product. Um, Thank you, sir. And what we use in our website to actually sell, what we're going to use in our website to sell our product is WooCommerce. It's already set up, but what it is it's a flexible open source commerce solution built on WordPress. So this plugin is going to keep track of our performances, how many perfect pools we're selling, how many orders we have. It'll show us how much we're being taxed for it, returns, shipping, stocks, etc. We just thought that this was the perfect thing to use for what we're going to have set up in the future for our online store. And to the next slide. And one last thing we want to talk about, possible future improvements. These have all been tested. We just don't have the resources to do it at the moment, but this will be something that we implement in our MK2 model of the perfect pool. The first thing would be to add a small solar panel to the device. Right now, as you've seen in the video, we're using a V8 battery, which is also comes with that 8-pack of AA batteries. We have tested this and it lasted about a month. So we're looking for something more long term so our customers won't have to buy so many batteries in the future. You don't want to scare them away just because I don't feel like going to the store to buy AA batteries. Another thing we're doing is substituting the Arduino Mega with a Node MCU board with integrated Wi-Fi. This will allow us to do updates over the air, and will also make our device smaller. So when the MK2 is produced, we'll be able to actually show a smaller, better build of our device that's easier to carry around. We're also going to reduce the number of sensors needed by using probes with multiple sensors. So right now we have three. We have the temperature, ORP, and pH. What we're doing is to shorten that to maybe one or two. They do have probes that have multiple that can use multiple sensors. And the last thing we're going to do is the light that you saw inside that you have to unscrew to look at it in the box. We're going to make it to where it's going to be at glance, so where you can see that the light is showing connected and ready to use, so you don't have to unscrew everything. And now I'm going to go ahead and pass it to our business developer, Jacob Blucor.
Thank you very much, Montreal. All right, guys. Really excited to represent PerpHect Pool. We're going to talk about the business side now and explain how feasible this is and how exciting it is, quite frankly. So first off, I'm going to go ahead and explain to y'all our fixed monthly costs. Our rent and utilities will run us about $1,000, 35 and 20 cents. Salaries and labors we pegged at 17,500. The Blink app, which once again is a very useful app for our product, is running at 166 right now. Once we break the limit of 1,000, it'll run to 499. I believe it upscales past that, but it's a good thing for us to run off of. Doesn't go too high. The total fixed costs will run us at 18,701 and 20 cents. The current consensus from all members is that the salary for all 6 of us will be 35,000 for the year, starting out. We'll go to the next slide. Now, our prototype costs. So as we mentioned earlier, we had to start off with the Arduino Mega, the box, our breadboard, our battery pack. Then we had our pH sensor model, our reference solution, our ORP sensor module and reference solution, the Wi-Fi, ESP8266 module, the Wi-Fi adapter, and the temperature sensor. All of that came out to a total of $199.91. And in the next slide, you'll see something quite interesting that I'll point out is, as our guys mentioned before, we went to a Node MCU, which would allow us to make it much smaller, which was much better in the overall. The other thing that you'll notice is different from the prototype is we have the pH and temperature sensor module. Originally, those were separate sensors, but we found one that combined them into 2, and that went to $40.99. The pH reference solution, which was $850, ORP sensor module and reference, which was $79.99, battery pack $2. So all of those kept it about similar to previous. The difference in the variable cost right now is currently the shipping, which is $39.85. And then the sending 6 pounds or more is $19.99, and the packaging, which is $10. So overall, our total variable cost came out to $222.32. Now, how are we going to keep up with these costs that I've just explained to you? So we're going with a subscription service approach, similar to Amazon, Spotify, things like that. So what's really interesting is we did some research in any other markets that are currently selling a product similar to our own tend to sell everything for wholesale. Therefore, they tend to make their money up front. They'll sell it closer to $1,200, something of that range. Instead, we're going at a different approach. We're going to sell base revenue roughly at $80 per unit profit. The selling price is $299, and the total production cost is $222.232, as I mentioned. So we'll be selling closer to at cost to try and reach out to a untapped market, as we've found. The total is basically they'll pay $60 up front. They'll pay $60 for a year, which runs out to about basically $5 per month, which most of us use for. Most of us have subscription services for Spotify, Chegg, things like that. So it's something that's already proven in the market. The product sales and gross income for the year 1 runs us about $400,000 if we get 5,000 units sold. My colleague Peyton will explain why that will be very easy for us. The subscription service gross income for year 2, as I explained previously, the first year will be to get the target market. We'll get the first year free for those who buy the PerpHect Pool product. They'll get the first year free, and then the second year is when we start accumulating on that revenue service for the subscriptions, and that'll be $300,000 based on 5,000 units sold. And so now I'm going to pass it over to Peyton, who's going to talk about our marketing and all the customer segments and interesting things and how this is going to be very possible. Peyton?
Thank you very much, Jake. Glad to be here representing PerpHect Pool as well. I'm going to talk about our customer segments. First off, how are we going to reach these people, and a little bit of the research that we did on who those people actually even are. Pool and Spa is a big website that I used for research. They have a lot of aggregate data on pool owners, what they like, political affiliation, and all that. But the two big things that I found for them were that they have the average pool owner is aged 35 or older, and the average pool owner's salary is $76,000 a year, which means a $300 device that saves you a lot of time and only costs pretty much $5 a month to keep up and keep track of your pool. They would probably be very inclined to get that. We're also going to try and reach out to gyms and hotel chains. Most gyms and hotel chains have access to pools for their clients, and so if we could get a contract with them to have our product installed, I think it would not only bring in that revenue, like I mentioned, but also entice people to get it to their pools at their own homes if they see it being used in that way. The main way that we're going to try and reach customers in the private sector is going to be with ads resting on Google and Facebook. Most ads like that are targeted in an area. I've found through a little bit of our research, all over Google. So it's more by area, and we're going to be targeting those highly populated metropolitan areas, but I'll get to that more in a little bit, as well as Google sponsored links we're going to try and use with Google whenever people do search for these terms like pool monitoring, automated maintenance, stuff like that. We're going to try and get our link to be at the top of that page. For hotels and gyms, we're going to reach out directly for contracts and try to see if we can go directly to the manager or whoever's in charge of that area to see if they would let us be the people to monitor their pool for them. If you could give me the next slide. Thank you. Potential partners in this, we're going to be trying to work with chemical distributors. We don't distribute the chemicals yet, but that is another thing that we're going to work towards. We will also try to reach out to homeowner associations. If you have a pool on the block, got to have the PerpHect Pool. I think it's a really good selling point, and it'll help us reach out to those people. Pool installation services, if we're able to get the PerpHect Pool in whenever the pool's installed originally, it's very enticing to keep that and institute that switching cost right at the start. So I think that would be a very good idea for us as far as potential partners. Here's our market, roughly. And like I mentioned earlier, we are going to target those high population areas. We did a little bit of research on this, and 10 million pools is the total amount of people. We had to narrow that down a little bit because probably half of that are actually tech savvy and would be interested in a device like this. So that brings us down to about 5 million. And maybe half of those people already have a pool service like Leslie's Pools or a pool cleaning service that they already use. And we would cut that in half again to go down to 2.5 million. And then we are going to target the high population areas. So that'll keep us a little bit afloat there. But that'll still bring us down to about 1 million potential customers, which going from 10 million to 1 million sounds bad, but when our goal right now is just to get the 5,000 units out and get that subscription started, that's not even 1% of our target market within the first year. And like I said, high population areas, we're going to be looking at Phoenix, Tucson, Houston, Austin, the Miami part of Florida, which are all real hotspots for pool ownership. So with all that in mind, we would like to open the floor for any questions.
Yes, I had one question. I was just wondering, Device Pilot is ranked a little bit more highly in terms of sophistication. So why exactly did you choose Blink instead? Rachel, I don't think we can hear you.
Sorry. We chose Blink because it better supports Apple and Linux products. It also has that 24-hour support that we really need for us and our consumer base. We want to really serve the people who purchase our PerpHect pools. So it is essential that we support any product that they may have. We don't want to limit our device to just Android users or just Windows users. The pricing model also doesn't scale as well. So while it's a more sophisticated, model, the pricing is just not nearly as good. We also like to kind of support our American economy, and Blink is backed by an American company, whereas that one is actually from the UK.
All right.
I'll speak to the hardware side a bit for that. Blink actually is a known IoT sort of back-end service. So they really do already kind of have some market here. So really from the development standpoint, when you're really trying to do accelerated prototyping, they really make it a lot easier.
And also, if I can elaborate on that, it allows us to kind of have our beta version of the system distributed to 20 different starting customers and have them run them for some time, collect some troubleshooting issues, and all of that for free. So for the first 20 prototype versions, they're serving us for free. So that was one of the key points why we chose Blink as well as the backend service.
All right. Thank you very much.
Thank you.
Thank you.
It's a good question. Anybody else?
I guess I've got a question, IT as well. I guess it's directed toward Montreal because he was the one that talked about it. I guess I don't know if I just missed it, but I guess how many sites do you have? I guess I didn't understand how that worked, like the multi-site website or.
Yeah, so with especially with when you're setting up with AWS, you can actually in the main screen make separate domains. Dr. Shoemaker pointed this out to me. This was not a good idea. He directed me towards multi-site, which is where you just use one IP or one domain, and you can actually make other websites within that one. So you won't have different admins. You just have one admin that does all the downloads for you, and everybody else can go ahead and just, as soon as it gets downloaded, since you have that admin right, everybody else can use them. But you also have your own folders with images and all your safe stuff in it. But it was just mainly because we had the free trial of AWS, and having 2 or 3 open domains was probably a bad idea.
Okay. So I guess how would you access these separate websites? Do they each have their own domain, or is it all under?
So
Say for example, I'm sorry. Go ahead.
No, go ahead. I'm sorry.
I guess I'm just wondering, what would you type in to access each individual website? I guess. I guess I just have a hard time understanding how the multi-sites work.
Oh yeah, so it'll still have the same IP or domain, but at the end you can actually name it, or at the beginning you can actually name it whatever you want. So on the picture on the slide, there was actually one that said perfect in the IP address, and there was one below it that said pool and then the IP address. The main one just had the IP address, which that was the admin. You can also make a website from the admin, but in our case, we only had the websites from Perfect and Pool after and then IP address. So,
Okay, that makes sense. All right, thank you.
no problem.
So I just want to give everybody the opportunity to answer a question. I was more thinking along the lines of what was the most challenging parts in putting together this project. It might be more of a CS oriented question, but I'd still be interested to hear about like the business plans and whatnot.
Of course.
Yeah, well, I'll cover at least a part of it. The Wi-Fi connection is, we chose the wrong board to start out this prototype, plain and simple. Like the Arduino Mega is powerful for processing, but actually getting connected to Wi-Fi through a shield presented us with some other limitations later. The chief I spoke about a little bit in the PowerPoint is that the Arduino sends 5-volt signals, and it needed to be converted to 3.3 in order for us to use the ESP without frying it. And then on top of that, some of the Blink API requires that you don't use a shield like the ESP8266 be referred to as, and instead that you use an integrated chip. So personally, I found that the most challenging.
Yeah, as far as the CS side, in addition to that, neither Daniel nor I had any experience with hardware before this project, honestly. So I think that was the most satisfying and the hardest part of the project to get going with just calibrating sensors, reading in some values, and then along the way those higher level issues arose, as Daniel mentioned, with the Wi-Fi module and Blink's API compatibility with it. But at the end, we got it to work and really like how it looks like. So it was a great feeling, honestly.
To answer your part about the business portion, I think me and Peyton, for the most part, found the idea of trying to figure out whether we were planning on keeping it as a company to build off of, or whether it was something we were originally going to sell to other vendors. So we went back and forth on that for a little while throughout this whole process. And it was actually kind of exciting to figure out. We had a very productive meeting, and Peyton made a lot of good points. And the fact is, we were able to kind of create our own market for it with a subscription service, looking at all the competition, doing wholesale. So as Peyton mentioned earlier, Peyton made a good case for the switching costs for a lot of people. Once you kind of have that service that you have been using for a couple of years, you create your own market and your own customer base for it. And then if anyone else decided to enter the market later after we started, we would be the first to market.
The thing that really threw us off in the beginning, we saw other people or other companies with a similar idea going that wholesale route and selling for, close to $1,000. But that was it. They had the $1,000, and then maybe you got a warranty or something with that for X amount of years, but that was the end of that revenue stream. Moving into something that would continue to create revenue for us was something that we didn't think of until we had the Small Business Development Center meeting. Tyler, when we met with him, and he said this looks like a perfect idea for a revenue-based or a subscription-based revenue stream. It would only take us about 3 years with all of that, or everything that we mentioned before, the 5,000 units, 3 years to cap that off, and then just everything from there on out is straight revenue for us. The devices have paid themselves off.
And to add on to that,
Go ahead, Macho.
oh, my bad. To add on to that, I would say the most challenging part for me, being system support, you're the one setting everything up besides the hardware. So you're setting up all this back end stuff. So if something goes wrong, somebody's coming to you. You got to figure it out. Like, you're the guy with all the access. Like, and that's really challenging. Gave you a glimpse of the real world, like how people are going to depend on you in the future, like to run these operations. And you're basically on call. So when they need you, you gotta get up and try to figure it out.
Yeah, Montreal did that for us while I was working when we had to figure out the two website deal, because me and Peyton were constantly sending him messages in Slack of, hey, any idea how this works? And he read up on it and called Dr. Shoemaker and everything, and all got working. So
Okay, so what are your next steps?
One of the major things we wanted to do in the near future was to simplify both the size and the hardware inside the device. So as main thing would be switching to a board that has Wi-Fi integrated chip in it, so that we don't have to deal with the Wi-Fi adapter, Wi-Fi module, just to communicate to the internet. If we had a Wi-Fi chip integrated in the board, that would reduce the cost and both the size of our device. And in addition to that, I think a really important thing to incorporate soon would be the solar panel, in order to avoid any battery issues, users complaining about the device not being able to run for a couple months and stuff like that. So those are the kind of the weakest points of the prototype that we established, and I think those will be the first things to incorporate in the nearest future.
Okay, have you considered maybe using a Raspberry Pi? Because a Pi can put out a 3.3 volt
That's
signal.
true.
Yeah, we have.
And also have your Wi-Fi.
The Raspberry Pi is much more expensive. These
Yeah.
Node MCU modules we can buy, I just bought a few, to test with our code, and I got 3 of them for $14. So I just don't think the Pi can compete with that, and we don't actually need that much power, computationally speaking. So at this point, with an integrated chip in the Node MCU, we don't have to step down the voltage anymore. With that integrated chip, it's just ready to go. And in the Mark III, we're moving on beyond that. An actual dedicated circuit for this device would be ideal, because what we need is the internals to be completely waterproof. The box we're using actually is waterproof. It's more weatherproof. It's an outdoor junction box that we've sealed the holes where we've at the ports. So all of that is okay, but if we can get the circuit even smaller, we can make this such a small device. And that's really appealing to consumers when you just don't even notice that it's there. You just get only the convenience and none of the inconvenience.
And also, a Pi would be an option in the future if we can, for example, partner up with sensor producing companies. That way, reduce the cost of getting the sensor hardware in. And with the Pi, we can increase the computational power, add more features maybe. But as far as the price point, as Daniel mentioned, the Node MCU boards would do pretty much everything that we need right now for $4.50, about $4.50 for each board.
They're really efficient.
Yeah, it might be good later on once we maybe, if say like, we talked about in 3 years or whatever, once the devices have kind of paid themselves off, and maybe once the company or whatever has a bigger name, you could actually approach maybe some of those vendors and see if they would be more interested. Absolutely. After you've already kind of got
what we found is that a lot of these sensors are made to order. So if you place a large order, they can cut you a much better deal than you can do buying one-offs from them, just like with anything, that economy of scale. But yeah, with these sensors, definitely the crux of this entire project, and they're also the most expensive parts of the project too.
Okay, well, thank you for that.